We start off looking at the actual microscope itself. We've got the eyepiece lens on the top. This is going to be the bit you look down, and if you notice on this one it actually says times 10, if you can see that on there. And that's quite a common thing, that this top lens will be a times 10 magnification. Underneath we have what's called the objective lenses, and it's always worth starting on the smallest of the objective lenses. In fact, you can't easily see it on here, but the smallest one there, it says times 4, and then we've got a times 10, and finally times 40. So if I'm looking down this eyepiece lens on the smallest, I would multiply the two together, an overall magnification of times 40. And we use the times there to show that it is actually a magnification. The reason we do this, a couple of reasons actually. It gives us the largest field of view. And what that means is I can see, when I look down the microscope, I can see the largest sort of, if I was looking at perhaps plant cells, onion cells, I would see the biggest view under the that magnification. If I was looking at it, say times, if I use the times 40 lens, my overall magnification would be 10 times 40 is 400. This time when I look at it, I wouldn't be able to see as much. I'd be able to see more detail, but I wouldn't be able to see as much of the field of view. So we start on these lower power so we can see more and then find out what we need. Of course, we've got our little focusing knob on the side, which will move the stage up and down, and this little dial on the side, it simply lets more or less light through, so we can adjust how much light gets in to see our sample. This is probably the trickiest bit, which is the stage micrometer, which they look like this. You won't be able to see it on here, but there's a tiny little ruler, if you like, on there. And this would go on the stage, and then what's called the Eyepiece Graticule, which would go in here in the eyepiece. And again, it looks like another little ruler. And if we looked down the microscope, it would look something at first like this. So you'd be looking down it, and you adjust it and you bring it into focus. Okay. Now, if I get it lined up on here, let's just sort of do it like that. What I'm trying to do is line up the number of the lines on the Eyepiece Graticule with the lines on the stage micrometer. So if I say between there and, let's see, yeah, between those 2 points. Okay, so I've got 1, 2, 3, 4, 5 divisions on my Eyepiece Graticule, and the same number of divisions on the micrometer is 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I use the colours actually, 5 spaces on my Eyepiece Graticule equals 9 spaces on my stage micrometer. Now what I do is, if I divide 5 by 9, using a bit of technology, 5 divided by 9, that tells me how big now each of those, each line on there is 0.55555 recurring. Okay. Now I put my sample underneath the microscope on the stage now, and when I look down, I can count across and say, that cell is 1, 2, 3, 4, 5, 6 of those lines across. So the real thing would be, my answer here is 3.3. But what does that actually mean? Well, on the stage micrometer, each of these little spaces is 10 micrometers. So if I multiply that by 10, it gives me an answer in micrometers of 33. We don't use recurring numbers in science, but that's how I make my get my size myself. Now you might be saying, just a minute, why don't you simply have that in the eyepiece and then you could look down on top of it? The problem is it's really difficult to get an accurate measurement. Your measurement has to be as close to the sample as possible, but why don't I just put that on top of that, for example? It just turns out it doesn't work very well. You can't really read the scale and see the sample at the same time. So you've got to go through this 2-stage process of working out how big each of these gaps are compared to the micrometer, work it out for one gap, then look at your sample. And every time you change the magnification you would have to do that, it would look slightly different each time.